welcome back to the shop. We're back on the bearing splitter project. So just to recap, we're working on making a custom bearing splitter that will grab this style inner race on a tapered roller bearing. And first thing we're going to do is we're going to bore a hole in this plate. I've already marked the center and center punched it. So let's line up here. We got the wiggler in the mill. That looks pretty close. Let's try it with it running. Alright, I think we got it. Okay. So we're just gonna bore a hole in here that's close to what we need, and then we're gonna finish it off in the lathe with the faceplate. So what we got is an 1.5" rotary broach. I don't think I've ever used this one. It's brand new. And we just got it in a 3/4 collet. Trying out a new light over here, so kind of gets in the way of the feed handle. See how this looks. So this is a 1/2" thick plate. Save us a lot of grief when we get over to the lathe. Alright, there we go. Gotta love these rotary broaches or annular cutters. Quick way to put a big hole in a piece of plate. Okay, so our next step is we're going to mount this to our face plate. So let me get that set up and I'll bring you guys back. So that's an 1.5" cutter. Let's see what we can see here. I don't know if you guys can see that or not. That's 1.5 plus a thou. There's 2/1000ths over. 15015. 1.5. That's pretty accurate. Okay, I don't know how well this is going to show up on the camera, but I've got our plate here against the face plate. I've got a bell center holding it centered and forced against our plate. And all I'm going to do is take a transfer punch. And it's a little bit of a challenge getting in here, but we've got some through holes, threaded holes in the back here. Okay, that one's making it, but you can see I am right there. I don't want to mess up my nice paint job. So just a little tricky getting around the camera here. Okay, let's see how we did. Yeah, let me take a closer look at this and see if I can figure out where we punched this. Okay, so we've switched over to Plan B. I just couldn't get a good center punch over there at the lathe. We were just too close to the headstock to get a good hammer hit on the transfer punch. So I've lined this up by eye, and for what we're doing here, that's perfectly good. So we're gonna go ahead and see if we can transfer a couple punch marks here. All right, I'm not going to bore you guys with the drilling process, so let me get these holes drilled out and I'll bring you guys back. Okay, we interrupt this video to repair a sewing machine. My sister-in-law just came by. She repaired, re-sewed a little pack that I had, and her sewing machine broke. So the light switch, I think, is broken here. Uh-oh, that doesn't look good. She saved a little piece of plastic that came off. Alright, well that switch is a goner. Alright, we're going to look in our... Oh yeah, look at that. Alright, we're going to look in our stockpile and see if we have something we can replace that with. Okay, we went through all our switches and really didn't have anything that would match up with what was there. I do have this style. I don't have the locking nuts, and it's much bigger. I'd have to drill out the bracket. Talked to my sister-in-law. She goes, I never leave it plugged in. The only time I plug it in is when I use it. I go, well, how about if the light just comes on every time you plug it in? And she's fine with that. So what we did is we just tied the switch leg together here. We're going to put a little heat shrink on there, and it will be a permanent on light. This is some type of a low voltage. There must be a transformer in there somewhere, because it's using an automotive style bulb, so it's only 12 volts or something in that range. Okay, that ought to be good enough. Then we got to tuck this wire back in there where it's out of the way. And clears the screws. Oops, got a little schmoo on me. All right, let me get a zip tie. Okay. Interfere. Looks good. Uh-oh. Oh, now we did it. Oh, no. Okay, all right. Get that back together. All right, let's put the end cover back on. She didn't bring the cord over, so I can't test it, and it's got a really weird plug configuration. All right. Oh, I think we fixed her up good and proper. Oh, it goes up in there. There we go. Now that we dropped our screwdriver on the ground. Okay, just plastic, so we don't want to overdo it. Okay, we get this off the bench and we'll get back to the original project. Okay, so hopefully Mr. Bozo has left the premises and won't come back, at least no more today. All right, so we got some spacers. They're gonna go here, 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 and here. And then our plate is going here onto the face plate. Let's see if our screws are long enough, it'll be okay. Probably didn't need these spacers, but I wanted to have a little extra clearance because we got to run the boring bar in there. We're going to find out if everything's going to clear. We can get the thread started. There she goes. That we don't hit the saddle here. We don't need to be in that close. This is just to center it up. Grab my wrench. Back these off a little bit. Getting a little bit of resistance, so we're probably off just a hair, but you know what? It's not going to make any difference. All right. Let me grab the wrench. We'll tighten that down. Yeah, she's a little bit off. I think we can do better than that. I think I'm going to enlarge these holes. and give her another try. Okay, well, I think I'm done for today. I think I'm going to pick this back up tomorrow. Okay, we're back over here at the South Bend. So I did a little more work on our setup here. I went back and I re-drilled our mounting holes, went one more size up, and added some washers also to these bolts. And I brought in our bell center and got everything lined up again and tightened down. So let's take a look at how we're running. Yeah, let's engage the drive first. That'll help. So we are running much better. I didn't put a dial indicator on it, but with the bell center in there, it's nice and true. So that's good enough for what we're doing. Okay, now we need to set up to bore our final dimension, and it's going to be at an angle that will match the bearing race. So let's take a look at that. We're trying to determine the angle of the inner race cone here, the contact angle, because we need to reproduce that in our bearing plate. So I did I don't know how well it's going to show up, but I did the calibrated eyeball check, and I've already done this off camera, so we're just revisiting here, and got pretty close. But then I found a ground pin. It should be fairly accurate, and this is really hard to hold. You need about at least 3 hands, maybe 4, to hold everything. But I put the light behind here, and we're real close, and plenty close enough for what we're doing. Okay, you would think you could look up this the spec on this bearing, which is a 3207. Oh, there you go, 3207. I scoured the internet for quite a while, and you can find quite a few diagrams that show the apex angle, illustrate, and also the contact angle for both the inner and outer, but they don't give you what that angle is. They just give it an arbitrary a variable number. So we had to resort to measuring. So and I don't think you guys are going to be able to see this, but it comes out to 70 degrees, or opposite of that would be 20 degrees. Okay, so we're going to go over to the lathe, and we're going to set that angle on the compound on the lathe. Okay, we're handheld here, so sorry for the shakiness. But anyways, here's our compound. We've got it set at, hopefully that's showing up, 70 degrees. So we got our protractor. I haven't changed anything on the protractor since we checked the bearing. And this is, really need 3 hands to do this, but let's see how we're tracking here. I don't know how well that's showing up, but that's pretty doggone close. I got a light underneath. We've got a light on top. All right, let me turn the light on top off here and see if I can hold this thing steady. Anyways, I think that's going to be good enough. That looks pretty good. And it's good enough for what we're doing. I mean, we're not looking to get an exact fit on that bearing race. We're mainly trying to grab the flange. Okay, so here's our high-speed cutter after we touched up the grind on it. I did rotate the boring bar just slightly, so we got a little bit of back rake. There was no back rake ground into it. It was just flat on the top, so I think that'll work a little better. So, okay, let's set up to bore this.